Statistical mechanics is mathematically complex to some extent. Methods of probability theory and statistics in particular, the mathematical tools are used to describe and predict the macroscopic parameters of a system in equilibrium from the knowledge of the microscopic properties using the laws of mechanics. As an example, the temperature of a gas is related to the random motion of the gas molecules. The faster they move on average, the higher the temperature. It must be noted here that Maxwell's kinetic theory of gases is said to represent the starting point in the development of statistical physics. Its foundation was laid towards the end of the 19th century by Maxwell, Boltzmann, and Gibbs. Albert Einstein, to a large extent, completed statistical mechanics in 1905. Basics of temperature, heat, work, state counting, probability, entropy, laws of thermodynamics, partition functions, and the Boltzmann distribution, applications to engines, refrigerators, computation, and phase transitions are some of the major topics in statistical mechanics that have significant applications in other fields such as economics and computers.